So for those kind of questions, like number 10, 11, and 13, 14, so there are several objects that are connected to each other. The common thing is if they are accelerating, they have the same accelerate for all of them because they are linked together. So that's the K for those kind of questions. Here is tension. 1, 2. So if you think these three as a whole, the only force is this F, right? And then this F is equal to all the mass. Acceleration.
So it's 5m times a.
Yes. 5 times A.
Okay.
The question is asking you, we don't know F. In the question, it tells you the tension here. T1 is 12 Newton. So T1 actually is the force that have effect on these two.
Right.
No? So it's M plus 2M acceleration.
So it's 3m times a.
So it's 3 M A. And T1 we know is 12. Right? So from this, you can just solve the problem. 5 MA. From this we know MA is equal to 4. Right? 12 equal to 3 MA. MA equal to 4.
Okay.
Okay? 5 times 4 is 20.
Wait. I get the 4 part, and then we get the 5 from.
F equal to 5 M A. The 5 is from 5M. You got this part, F equal to 5 MA.
Mm-hmm.
You got here, 12
Right.
equal to 3
I don't know how does that 4 and 5 get together?
So
I get all the separate calculations, the force.
you got this and
I got
this.
that and I got that, right.
Okay.
Now how do you put them together? I don't get that.
Okay. So right now you can calculate, for example, A here is equal to 12 over 3M.
So that's 4 over m.
4 over M. You got this.
Right.
So you just put the A to here. So 5M times 4 over M. So A is 4 over M.
Oh, okay. So the m's
Uh,
cancel.
yes.
And it'll be 5 times 4.
Yes. So it's 20.
I got it. Let's move
So
on.
it's just a calculation.
Yeah, it was just a calculation.
Yeah. If you got the concept, it should be easy. Number 11 is kind of similar. So big kilogram, 5 kilogram. And you have force to push these 3 blocks together. So the question is asking you the magnitude of the force exerted on block 1. That's block 1, 2, 3. On block 1 by block 2. So here we can isolate number 1 here. So here is number 2, number 3. For number 1, it has the force here, right? It also have a force from block 2 to 1.
Right.
Okay. The same thing. Here we want to calculate. The only thing we know is for all the blocks, they share the same acceleration.
Right.
So from this, if we look at 1, 2, 3 together, P is the only force equal to it's 2 kilograms, 3 plus 5,
So it's 11.
no, is 10. No? 5, 10.
Yeah, 10. I'm sorry.
Yeah.
I was looking at it wrong. It's 10. You're right.
Yeah. But that's just calculation, it's fine. And it's MA you got here, right? And right now we look at only block 1. When you look at only block 1, the force is, apparently there is P, but there is also F21 in the opposite direction from block 2 to block 1, right? So that's the total force in block 1. And it gives this block 1 an acceleration of the same A. But block 1 is 2, the mass. Right? So we know P from the question is 6 Newton. So we can calculate A equal to 0.6 from this. Okay? And then we put everything into this equation. P is 6. We don't know the force from block 2 to block 1. We know A is 0.6. So 6. If you solve this equation, you got the force is 4.8 Newton.
Okay.
The only thing is, remember all of them share the same
acceleration.
acceleration. So these two are similar kind of questions. Number 12, 8 kilogram object rests on the floor of an elevator, which is accelerating downward. So acceleration is 1.3. The question is asking you what's the magnitude of the force the object exerts on the floor. So it's the same as asking you what's the force of the floor acting on the object, right? So the support and the gravity we know is accelerating downward. So equal to MA, right? And if you put everything there, A times, let's say that's 10, equal to 8, 1.3, equal to 80. So it's around 69. The question is 68. D. The answer.
Does it matter the arrangement you put mg minus Fn because you have rolled it F minus mg because mg is going down?
Yeah, because we know the movement